Welcome, everyone. A peculiar object has recently been drawing attention from some of the most esteemed scientists in the world. A professor at Harvard has introduced an intriguing theory, suggesting that what we are seeing might not be a comet, but rather a piece of alien technology. Right now, an object like no other is hurtling toward our sun at a speed of 36 miles per second. This strange visitor is carrying ice older than our planet itself, forged in the heart of a star system that existed long before the formation of Earth. In the following account, we will witness the moment when astronomers first observed this interstellar traveler, learn why it is defying all known expectations, and understand how a small speck of ancient cosmic dust could be reshaping our understanding of space. This is the story of the third confirmed visitor from beyond our solar system, a traveler that has journeyed through the void of space for millions of years, far outlasting the existence of life on Earth, only to reach us now. Prepare for a fascinating adventure as we uncover its secrets. The robotic eye that scanned the southern sky was not looking for mystery, but for danger, potential threats that could end civilization in mere minutes. But what it found instead would challenge everything we thought we knew about celestial visitors. The Asteroid Terrestrial Impact Last Alert System telescope, located in the Atacama Desert of Chile, had been designed to detect hazardous rocks that could collide with Earth. Instead, it discovered something that shouldn't even exist. A faint dot of light moved against the backdrop of stars, but this was not behaving like any asteroid or comet previously recorded. The object was heading in a direction that defied all expectations. To understand this anomaly, imagine our solar system as a giant whirlpool, with the sun at the center and planets orbiting in predictable paths. Everything born within this system follows these natural flows, like leaves caught in a stream. But this object wasn't following the flow. Instead, it was swimming upstream, cutting across our cosmic neighborhood in a manner that couldn't be explained by known physics. It wasn't on any orbital path that could allow it to be bound to the sun's gravitational pull. Almost immediately, the team at the telescope realized they had discovered something extraordinary. While most space rocks drift through the void at speeds measured in thousands of miles per hour, this one was traveling at a speed that seemed completely impossible. Early estimates indicated it was moving so fast that it could escape not only our solar system, but also the gravitational influence of nearby stars. This discovery shook the astronomical community to its core. If these calculations were correct, this could be the third confirmed visitor from interstellar space to ever reach us. The first was the cigar-shaped mystery known as Oumuamua, discovered in 2017. The second was Comet Borisov, detected in 2019. But this newcomer was unlike either, in ways that made even seasoned astronomers pause. Whereas Oumuamua had been roughly the size of a football field and Borisov had been comparable to a city block, early calculations suggested that this new object was several times larger, potentially even miles across. The team realized that they had just uncovered a cosmic time capsule from deep space, a fragment that could reveal secrets that had been locked away for billions of years. Within a span of just 3 days, observatories across 6 continents redirected their instruments to focus on this unexpected cosmic visitor, desperate to capture every bit of data before it disappeared into the void. As the months passed, the urgency grew. Every precious photon of light from this ancient wanderer could hold the key to unlocking mysteries about the space between stars. This was the beginning of a new chapter in our understanding of the universe. The excitement surrounding this interstellar visitor reached a new height when astronomers calculated its speed. Imagine standing on the side of a highway and watching cars move past at lightning speed. This is essentially what astronomers discovered when they measured the true velocity of this cosmic traveler. It wasn't just fast. This object was racing through space at 36 miles every single second. To help grasp the significance of this speed, imagine being able to travel from New York to Los Angeles in less than 2 minutes. A journey that typically takes 6 hours by plane would be completed before you could even finish reading this sentence. This astonishing speed shattered all previous records for interstellar objects. In comparison, Oumuamua had traveled at around 16 miles per second, and comet Borisov was slightly faster, moving at 20 miles per second. But this new object was moving nearly twice as fast as anything that had been observed before. What makes this speed even more remarkable isn't just the raw number, it's what it reveals about the journey this object has endured. Just like a detective can piece together the story of a crime based on the trajectory of a bullet, astronomers could read the object's journey through its speed and direction. The faster an object moves, the more energy it takes to accelerate, and the more violent the event that originally sent it on its way. This object had been launched into space with such force that it achieved what scientists call hyperbolic velocity, meaning it would continue speeding away from the sun and not return. It had been flung with so much power that it would not only escape Earth's gravity, but that of the entire solar system. The speed also meant that time was of the essence. Unlike asteroids and comets that orbit the sun for millions of years, allowing for decades of study, interstellar visitors are fleeting. They pass through our solar system like shooting stars, and once they leave, they are gone for good. At 36 miles per second, this object would complete its journey across the solar system in less than 2 years, spending only a few months in range of Earth's most powerful telescopes. And so, the race began. Scientists around the world scrambled to secure as much observation time as possible. Every moment became a rare opportunity to learn about the object before it vanished into the darkness of space. This was an astronomical gold rush, and every observatory director knew that. They were witnessing something truly unprecedented, a chance to capture data that might not be available again for generations. As the object's speed captured global attention, scientists soon realized that its trajectory held even more startling information. When astronomers traced its path backward through time, they discovered something that stunned even the most experienced in the field. This object hadn't just wandered in from the edge of our solar system. It had traveled across the vast emptiness between star systems, journeying for millions of years through what is often referred to as a cosmic desert. The proof of this incredible journey lay in a concept called orbital eccentricity. Orbital eccentricity is essentially a measure of how elliptical or circular an object's path is around a star. Objects within our solar system have an eccentricity of less than 1, meaning their orbits form closed loops around the sun. But objects from interstellar space, like this one, have an eccentricity greater than 1, meaning their paths are open-ended and they are not bound to our sun. This object's eccentricity was measured at 6.2, the highest ever recorded for an interstellar object. For comparison, Oumuamua registered 1.2, and Comet Borisov had a value of 3.6. The exceptionally high eccentricity of this object meant that it was following the most hyperbolic trajectory ever observed, confirming its interstellar origin with absolute certainty. The calculations also revealed something even more astonishing. When scientists traced the object's path backward through the galaxy, they discovered that it had entered our solar system from the direction of the constellation Sagittarius. This was no random wanderer. It was a visitor with a clear destination, following a precise path across the galaxy. But proving its interstellar origin was only the first challenge. Scientists now needed to confirm that the gravitational pull of our sun couldn't possibly capture such a fast-moving object. This required more calculations, a sort of cosmic forensics, where the astronomers used every piece of data available to ensure the object's trajectory was not being altered by our sun's gravity. The results were definitive. Even if this object passed directly through the sun's corona, absorbing the maximum gravitational acceleration, it would still possess enough velocity to escape our solar system completely. It was clear now. This was the third confirmed interstellar object in human history. The confirmation of the object's interstellar origin was just the beginning. As scientists gathered more data, they were astounded by the size of the object. Early size estimates suggested that the visitor was between 6 and 12 miles across, making it far larger than either Oumuamua or Comet Borisov. To grasp the scale of this discovery, imagine standing next to a football field. Now imagine an object several times larger, roughly the size of an entire city, with suburbs stretching far beyond the horizon. This was the size of the cosmic visitor that had just entered our solar system. Measuring the size of such a distant object is no easy feat, since it's impossible to physically measure something that is billions of miles away. Astronomers had to use light itself as a ruler. By analyzing how much sunlight the object reflected and comparing its brightness with its distance from both the Sun and Earth, they were able to estimate its surface area and therefore its size. The Hubble Space Telescope played a crucial role in providing the sharpest image ever taken of an interstellar object. The image revealed a glowing comet-like shape with a bright central nucleus surrounded by a vast cloud of dust and gas. This coma, as astronomers call it, stretched across thousands of miles. Within this cloud was a solid core composed of ice and rock, material that had journeyed across the galaxy. But the size wasn't just impressive. It told a deeper story. Larger objects like this one can survive interstellar travel in a way that smaller objects cannot. Over millions of years, cosmic radiation and micrometeorite impacts slowly erode anything exposed to space. But the larger the object, the more likely it is to withstand this weathering. This visitor's substantial size meant that it had endured the harsh conditions of deep space, emerging largely intact. Its outer layers may have been stripped away during its long journey, but enough material remained to create the stunning display now visible to telescopes. Every grain of dust escaping from the nucleus represented material that had been forged in a distant star system. As it mixed with particles from our Sun, it created a cosmic interaction unlike anything ever seen before, offering a glimpse into the conditions of another star system. What makes this discovery so extraordinary is not just the size of the visitor, but the rarity of such interstellar objects. In all of human history, with thousands of years of watching the skies, only 3 objects from beyond our solar system have been confirmed. That's fewer interstellar visitors than the number of humans who have walked on the moon. The rarity of these encounters only adds to the significance of the current discovery. The universe contains more than 400 billion stars, many of which have their own planetary systems. One might expect that countless objects, comets, asteroids, and other debris, are constantly being flung into interstellar space, creating a steady stream of wanderers moving between the stars. But in practice, finding these nomadic objects is incredibly difficult. Most of them are small, far away, or move through regions of space that our telescopes don't monitor. As a result, the fact that we've confirmed just 3 interstellar visitors shows how fortunate we are. This latest visitor marks a significant shift in our ability to observe the cosmos. Recent technological advances in telescopes and sky surveys have made it possible to detect these elusive travelers. But even with these advancements, finding interstellar objects is still a rare event. Objects like this one that are large and bright enough to be observed in detail represent an extraordinary opportunity for scientists to study them. Each discovery of an interstellar object is like finding a needle in a cosmic haystack. The sheer improbability of such an event is staggering. Our sky surveys, like the Pan-STARRS and Atlas telescopes, have expanded our ability to monitor vast portions of the sky, dramatically increasing the chances of spotting these elusive wanderers before they disappear into the darkness. But even the best surveys have limitations. Objects arriving from the direction of the Sun or from areas of the sky densely populated with stars can remain undetected. The fact that we've detected only 3 confirmed interstellar visitors suggests that many more have passed through our solar system unnoticed. Each of these missed opportunities represents lost scientific data that could have provided unique insights into the conditions of distant stars and their planetary systems. And while we've managed to capture images of this latest object, there are likely many more waiting to be discovered, hidden in the vastness of space, on trajectories that never bring them close enough for our telescopes to detect. While its speed and size had already made this object extraordinary, what really set it apart from previous interstellar visitors was its behavior. The visitor did not remain a passive cosmic wanderer. Within days of discovery, observers noticed clear signs of comet-like activity. A fuzzy atmosphere, known as a coma, began to form around the object's nucleus, and a faint tail began to emerge as solar heating vaporized the ice and rock within. This was in stark contrast to Oumuamua, which had remained mostly inactive, offering few clues about its composition or origins. Oumuamua's elongated shape and lack of visible outgassing left scientists puzzled for years, as it refused to behave like any known type of cosmic object. On the other hand, this new visitor was actively displaying comet-like characteristics, sharing its secrets with every passing day. Its tail grew larger as more material was released, creating a dynamic show for astronomers to observe. The coma, formed from vaporized ice, spread out like a halo, while the tail grew longer and more prominent as the object drew closer to the Sun. These developments offered clear evidence of the comet's composition and origin, suggesting it came from a much colder region than our solar system, where ice could condense and remain stable for billions of years. The most fascinating aspect was that the visitor's behavior was not just a random outburst. It was following predictable patterns based on known models of cometary activity. This allowed scientists to analyze its emissions and understand more about the environmental conditions in the distant star system where it had originally formed. Spectroscopic analysis revealed that water vapor, carbon monoxide, carbon dioxide, and organic molecules were streaming away from the nucleus. These were not just random chemicals, but complex substances that hinted at chemical processes occurring in its home system. Unlike Oumuamua, which seemed to accelerate in mysterious ways as it passed near the Sun, the current visitor was behaving exactly like a normal comet should. Its acceleration matched the expectations of astronomers, driven by the sublimation of ice as it absorbed more solar radiation. The visitor's ability to behave in such a predictable, comet-like manner made it an invaluable subject for study, offering clues about the chemical and physical processes that occur in distant star systems. As scientists continued to study the object's behavior, they made an even more profound discovery. The journey of this interstellar visitor had spanned millions of years, and it had faced incredible challenges along the way. Deep space, the vast expanse between stars, is often referred to as a cosmic desert, an inhospitable environment where conditions are harsh and only the toughest objects can survive. This object, however, had managed to endure the perils of space, traveling through this void for eons before finally arriving in our solar system. What's more astounding is how well this object had maintained its structural integrity over the course of its journey. As it traveled through the dark and cold void, it had been exposed to extreme temperatures just above absolute zero and subjected to the bombardment of high-energy cosmic radiation. Such conditions would be enough to break down most materials, causing them to erode and lose their composition over time. Yet, despite this harsh environment, the object had remained largely intact. Its size had allowed it to survive the intense space weathering that most smaller objects would not have been able to withstand. This resilience hinted at an incredible survival mechanism. The object's size played a key role in this endurance. Larger objects are better equipped to withstand the destructive effects of cosmic radiation and micrometeorite impacts. Smaller objects, on the other hand, are often destroyed during their long journeys through space, eroded by cosmic rays and impacts that break them apart. The size of this visitor, combined with the protection of its outer layers, allowed it to survive its interstellar voyage largely undisturbed. Despite the many dangers it faced, the object's composition remained remarkably well preserved. Its core, made up of rock and ice, had traveled across vast distances, protected from the destructive forces of space by the thick layers of material surrounding it. These outer layers had been slowly worn away over time, but enough material remained to allow astronomers to study it in unprecedented detail. Now, as it made its way through our solar system, this interstellar traveler was shedding some of its ancient material, revealing its inner composition. As scientists analyzed the emissions coming from the object, they could begin to reconstruct its journey and understand the survival mechanisms that allowed it to withstand the harsh conditions of deep space for so long. The discovery of this cosmic visitor marks a pivotal moment in our understanding of the universe. With this third confirmed interstellar object, astronomers now know that we are not isolated in our solar system, but part of a broader galactic community. These cosmic wanderers are like messengers, carrying with them material from distant star systems that we can study to learn about other worlds. The implications of this discovery are profound, suggesting that the space between stars is not as empty and desolate as we once thought, but instead is a vast, interconnected highway used by objects traveling between stars and solar systems. As this object continues its journey away from the Sun, the window for observation will soon close. Telescopes across the world are racing against time to capture every last bit of data before the object fades beyond the reach of our instruments. The opportunity to study an interstellar object of this magnitude will not come again for a long time, and the data gathered from its brief passage through our solar system will provide valuable insights for years to come. This is just the beginning. With advancements in observational technology, such as the development of automated sky surveys and more sensitive telescopes, astronomers are increasingly able to detect interstellar visitors before they pass through our solar system. The discovery of this visitor has highlighted how important it is to be prepared for such encounters, and future missions are already being planned to intercept and study these objects before they slip away. The European Space Agency, for example, is working on a mission called the Comet Interceptor, designed to wait at a specific point between Earth and the Sun for the next interstellar visitor. This spacecraft will be able to respond quickly, launching to intercept a new object, allowing scientists to gather data while it is still within range. These missions will represent a major shift in our approach to space exploration, from passive observation to active engagement with objects from beyond our solar system. Looking further ahead, we may even reach a point where humanity can send probes to study these objects up close, exploring the mysteries they contain, and learning more about the environments from which they came. By studying these cosmic travelers, we will not only learn more about the history of our own solar system, but also gain valuable insights into the processes that shape planets and stars throughout the galaxy. In the end, the discovery of interstellar visitors like this one is not just about the object itself, it's about what it represents. It's a reminder that the universe is far more interconnected and dynamic than we ever imagined. And as we continue to explore, we will unlock even more secrets that will shape our understanding of the cosmos and our place within it.